I'll be with you shortly. Um, yes, we can. Today's session might be a little, well, quite a lot shorter than normal, um, for reasons that some of you may be aware of, because I have been doing quite a lot of sitting in front of a screen today. Um, so I will go through the questions that people ask, and for those of you in year 10 and year 11, you know that there is extra stuff going on tomorrow, and there was today. So you are welcome to join some of that from 9 o'clock in the morning tomorrow if you want to. There are recordings of what I've been doing today somewhere as well on YouTube. At least one of them is. Um, but let me go through all of these questions first, and then I'll decide. For that last question, all of those questions I will see depending on. With these questions, I always decide whether I feel that you should know how to do it or not, based on the simplicity or difficulty of the question. So, let's see how many people are here. So basically, I did send an email, but I appreciate that not everybody always gets these, but mainly because it goes to your parents, and I have no control of these things. But today I did 2 hours of higher level maths stuff at 11 a.m. And then I also then did 2 hours of some science stuff from 3 till 5. Tomorrow at 9 o'clock in the morning, I am doing some more maths for a couple of hours. That will be more foundation level-ish stuff. So still relevant, but slightly easier stuff compared to that. And then tomorrow at 3 o'clock again, I will be doing some more science, but it's more triple science stuff. So that is very much relevant to those people. I only contacted the students in, or the parents of year 10 and year 11, just so you know, which is why some of you may have not heard of it. How do you join? What I'll do, I don't know how to do this now. Well, technically, there's a few things on. Oh no, how do I tell you? I did send an email, but I will. What I'll do is find it now. It is a link, which is not the same link that you're on right now because it's different. Um, oh, how am I going to find it now? Let's see if I can find it. Everybody on here is welcome to join it tomorrow if they want to, but as I say, it is meant to be more year 11 focused. Um, but you know what? It's a link. Please join it. It's like this. I've just put something in the chat. Now, that, if you copy, whoa, what just happened? Um, don't click on it now, obviously, because you'll disappear. I'll send the email as well tomorrow. It's fine. I'll forward it after this meeting. But hopefully most of you are aware of it. If not, if you go on Instagram as well, which I appreciate, not everybody has, but there is quite a lot of stuff in my face in various places, um, telling you that it's happening. But you'll be able to get to it and find what you need. But I can forward. I opened it up to everybody, so there are like 60 people on it this morning. Um, right. Let me answer the questions that people are asking, and then I will move on, assuming that there is question three on the year 10. Three on the year 10. What I'll do, given that there's one, oh God, there's a million year 10 questions. I want to do the 1 year 11 question bit first, right? Um, but anyway, the link that I've just sent on that thing is for tomorrow, so you can copy and paste that or whatever. 9 o'clock and 3 o'clock, I think, is when I'm doing the 4 hours worth of stuff. Right. Can we please do question one, B, C, and three? All right, question one, ugh, B. Is that right? One B. Um, B, C, and three E. Right, question one, B. Bum, bum, bum. Magnesium metal can be extracted from seawater. Seawater contains magnesium chloride. Calcium hydroxide is added to seawater. Magnesium hydroxide is produced. Um, Name a method that can be used to separate magnesium hydroxide from the solution. So This is magnesium hydroxide. It tells you it's a solid and it's in this solution. How do you separate a solid from a solution? You filter it, which should be the answer to the question. Let me just make sure. Question 1B, part 1 is filtration. So it's really about looking at the state symbols in the question to figure out how that works. B, C, and 3E. C. Oh, I'll just do part 2 as well. An acid is then added to magnesium hydroxide, magnesium chloride. Name the acid. It's got to be hydrochloric acid because it's magnesium chloride. Um, Fine. And then B, C, and 3E. Electrolysis usually extract magnesium from magnesium chloride. Why must the magnesium chloride be molten? In any electrolysis, we need things to be either in sort of, well, liquid form, so either melted or in solution, so that the ions are free to move. When you have a solid structure, the particles cannot move, as you should know from solids, liquids, and gases, in terms of the rigid arrangement and fixed structure, whatever they say. They can't move around. So by melting it, the ions can move around, which means that some of them can go this way and some of them can go this way, which is not possible otherwise. And three, oh, more of C, sorry. Why is this reaction an oxidation reaction? You should try and remember something called oil rig, which tells you that oxidation is loss of electrons, reduction is gain of electrons. This is an oxidation reaction because there has been a loss of electrons, which I appreciate the equation doesn't specifically tell you. But any question that says what is oxidation, say it's the loss of electrons. Anything that says what is reduction, it's the gain of electrons. Oil rig helps you remember that. Um, are lost. Okay, complete the equation for this reaction. I'm just going to do this quite quickly, but that is the completed equation. You just put plus 2 electrons and you get magnesium there. That is the half equation for that. How do I know from the equation of its oxidation reduction? Well, you don't. Well, well, you do, in that if you know this, then you kind of know. Because look, and this is where I think we can have a separate discussion about electrolysis at some point, but this equation is confusing because it doesn't quite explain how it's come about. The way this equation has come about, let me just go through this very quickly. This is a presentational thing. It should be shown a different way. So we have a chloride ion, and during this electrolysis, here are the chloride ions. What happens is they went there and they turned back into chlorine. That's what happened. So into a chlorine atom. The way they turned back into a chlorine atom is, well, the way to think about it is how did it become an ion in the first place? How does something become a negatively charged ion? It gains electrons. What does it do in order to get back to what it was? It needs to lose those same electrons. So what this chloride ion has done is actually lost an electron and turned back into chlorine. That's actually what's happened here. Because a negative ion, sort of to go back to what it was originally, which is what's happening here, needs to lose electrons. It must have gained them to start with. It's now going to lose them. And then basically this equation gets balanced because, so that's actually what's happening here. And there's the loss of electrons. What actually happens now is that because chlorine is a gas, it comes off as a pair. So we put a 2 there. And that means we have to put 2's here. That's actually the completed equation. And again, electrons are being lost here. The problem with what you're presented with from this equation is that we don't like putting subtractions in chemical equations. Just like we have, something plus something is something plus something. We always have pluses, everything being added. There's no minusing in an equation. And so they don't like this subtraction here. And so it gets represented by moving the -2 to the other side by making it an add, just like you do in a maths question by adding a subtraction to the other side. You end up with that equation. So I appreciate from that equation, it is not clear how you know if it's an oxidation or a reduction. But if you go back to what it originated from, electrons were lost. That's what oxidation is. Oxidation is the loss of electrons. That's my answer. Okay. Next one. Three E, and then I'll do all of the year 10 stuff. Um, I don't seem to have many more unless somebody else turns up in a minute. Year 9, question 4. Yeah. Okay, fine. I'll do that as well after this. Right, 3E. Oh, okay, right. The copper chloride solution. Okay. Okay. Concentration in chemistry is mass divided by volume. This is a concentration. This is a volume. Now, I appreciate that's a volume as well, but that kind of doesn't mean anything because it's one of them, so it doesn't actually change anything. So that's actually slightly a bit of a red herring, I think, that one. The volume of the solution is 50 centimeters cubed. However, 50 centimeters cubed needs to be converted into decimeters cubed to do this question because that's in dm cubed. To turn that into dm cubed, we divide by 1,000. 50 divided by 1,000 is 0.05. So I'm going to put 0.05 there. The question is calculate the mass of solid copper chloride. It's just that times that, I hope. So 300 times 0.05. 300 times 0.05 is 15. Is the answer 15 grams? Let me just check. Yeah, it is. Um, that's the answer. Anonymous attendee. Um, okay. That's three. Right, that's that. No, right, let me just do the one question in the year 9, question 4. Let me do that. So this was more, by the way, this week, this was more bonding and stuff in what year 9 and year 10 were doing, which is still, again, applicable to everybody. Question 4. We have ooh, a similarity and a difference in the structure of sodium and chlorine. Is a great question. Um, the difference, firstly, sodium is in group 1 of the periodic table, chlorine is in group 7 of the periodic table. That immediately tells us an obvious difference in that sodium, because it's in group 1, has one outer shell electron, whereas chlorine, because it's in group 7, has 7 outer shell electrons. Um, yeah, in terms of the question about what I'm going to do next week, hopefully, yes. As I say, if you are missing any of the stuff that I'm doing, it will appear on the YouTube, so you can just catch up with it. But I will try my best. I just don't know what's happening next week. I want to, I want to spend time with a child. So yeah. Anyway, um, so I will figure it out in terms of what I've got next week. But hopefully, yes, I will at least do at least one more um thing in the week. Similarity between these things. Well, the what you should notice is that they're in the same row of the periodic table. Now, the rows are called periods. That's period 1, where we just have those two. That's period 2, and that's period 3. Now, what the period tells you is how many shells that element has got. So, for example, the electronic structure of sodium is 281, and chlorine is 287. So they both clearly have 3 shells, right? 281, 3 shells, 287, 3 shells. So the similarity is the number of shells. Okay. Um, Right, that's that. Right, question B. Sodium reacts with chlorine to produce sodium chloride. Describe what happens when a sodium atom reacts with a chlorine atom. Uh, right by electron transfer in your answer. So what I want to say is that sodium is in group one of the periodic table. If it's in group one, as I just established, it has got one outer shell electron, which means when it bonds, it loses that one outer shell electron. When something loses the outer, now you probably don't need to say this next, but well, at least for this paper, for generally for GCSE, you do. When something loses one electron, it becomes an Na plus ion or a 1 plus ion because it's now lost more negative things than positive things. Similarly, if we do the same thing with chlorine, which is in group 7, because it's in group 7, it needs to gain one electron to get a full outer shell, and that's what it does. Effectively, that's the electron transfer. That one that this loses is the one that this gains. You see what I mean? That's the transfer. When chlorine gains one electron, it becomes a 1 minus ion. Um, probably don't need it for this particular question. I think that's probably it, but I would just go a little bit further. I just mean that for like a foundation level explanation. A proper explanation now says that these two oppositely charged ions attract. And then they form sodium chloride, NaCl. What's the next question? That's good. Thanks so much. Right, yep, fine. Um, and this question, again, I'll just do it quickly. Again, this technically wasn't part of the topic. It's just very hard to avoid questions from other topics when you do these things. Um, Exothermic. If it's an exothermic reaction, you need to go up and then down and finish lower than where you started. Very important. Lower than where you started if it's an exothermic reaction. Had it been an endothermic reaction, we go up, down, but finish higher than where we started. But we don't. We go up and down, finish lower than where we started. That makes it exothermic. Um, Anything else? Anything else? No, that's all the question for. Right, which moves me on to the question from year 10, which according to one person, I'm basically going to do the whole booklet here, but I'm not going to do that. So let's look through it. Um, are there any other questions outside that? Yeah, question 3 has been asked, and basically all of questions 1, 3, 4. So, oh God. Okay, right. I'll decide based on these questions if I'm going to answer them. 1E. I mean, I shouldn't have to answer this, but I will. Question 1E, we have a graph here showing the mass of sulfur dioxide in the Earth's atmosphere between 1984 and 2014. So we're looking at this graph. That shows the mass of sulfur dioxide in the atmosphere. A student said the mass of sulfur dioxide decreased every year between 1984 and 2014. I shouldn't really have to answer that question, I'll be honest with you, because does the graph show it decreasing every single year between 1984 and 2014? No, because here it's increasing, going up. Here it's staying the same. Then it's decreasing every year, right? So you need to explain that between 1984 and 1987, it increased. Between 1987 and 1990, it stayed the same. And then after that, it decreased every year. That's how you answer the question. Okay. So, no, the student is not correct. It didn't decrease every year. It went up for a bit, it stayed the same for a bit, then it fell. Um, you have also 1F, which shows some stuff. Calculate the percentage of sulfur dioxide released by industry. Okay. Again, I mean, really shouldn't be asking this question because the three the percentages add up to 100. Okay. If I want to know the percentage of this number here, 69 add 6 is 75. So that's 75%, which is out of 100, which means the remaining 25% comes here. It's just understanding that percentages add up to 100. Right, 1E, 1F, 3. I think I'll do all the question 3, don't I, basically? All right. Is it gone? Okay. Question 3. This is about group 1 elements. The teacher demonstrated the reaction of group one elements with water. What is name was given to them? They're called the alkali metals. Group 7 is the halogens. Group 0 is the noble gases. And they don't have a group. Okay. The teacher wore safety glasses and used tongs to handle the elements. Just one other safety precaution the teacher should take. I don't know. Gloves, maybe? No, that doesn't. Yeah, I don't know. Let's have a look what the answer says. What are we on question three? Question three says keep a distance, use a small piece of the metal. So look, we're using a piece of lithium. We know when we drop it in the water, it's going to fizz and do stuff. What we don't want to do is use a giant amount of it. So use a small amount of it. That would be a sensible answer. Um, use a screen is also a sensible answer. Sort of do it around the screen so when it fizzes and does stuff, it doesn't go into your eyes or whatever. I don't know. Yeah, that's a safety precaution. Right, then. This are the results. We know, and again, you're meant to know this. I'm just telling you stuff that you're meant to know, that as you go down group one of the periodic table, which goes lithium, sodium, potassium, the elements get more reactive. And these observations that you're reading demonstrate that it gets more reactive because here we have um, lithium moving slowly. That's a gentle-ish reaction. Then we've got it moving quickly. That's a slightly more faster reaction. And then here we've got very quickly, and a flame is seen. There's quite a lot of stuff going on there, right? It's getting slightly more violent each time. So if you, I think I've literally answered the question there. Describe the trend in reactivity in group one. You want to explain that as you go down group one, the elements get more reactive. First thing, how do we know? Well, you can explain that the as we go down, the element moves faster. So, it moves faster on the surface, slowly, quickly, very quickly. So moves faster. That's one observation as you go down. And then you can also say that, I don't know, potassium gives off a flame, which the other two don't. That should be sufficient, I think. Speed increase. Flame is seen with potassium, but not with the other two. That shows that you're getting more reactive as you go down. Safety glasses for B, not according to the mark scheme. I'm looking. Well, can you say safety glasses? Because I have already. Well, you can't say safety glasses in a question that I've already told you they're wearing safety glasses when it says give one other safety precaution. So you can't mention the one they've already told you. Okay. Um, so sadly not. Um, rubidium is a group one element. Rubidium is below potassium in the periodic table. Suggests why the teacher did not demonstrate the reaction between rubidium and water. Well, look, as you go down group one, it gets more and more reactive. So when you are, it's going to get dangerous and violent and whatever, right? If you, as you go further down, and there are YouTube videos of this if you wish to watch it. But the point is, it would be too reactive and it would be dangerous for the young children. Complete the balance equation. I'll just tell you the answer to the balance equation. There's two hydrogens there, two there. Oh no, sorry, there's three hydrogens on this side, which means I want to put a two there to make it four hydrogens on this side, put a two there to make it four hydrogens, and put a two, that's two, two, two. That's the answer. What is the name of the compound with formula NaOH? Is sodium hydroxide. OH is hydroxide. Predict this value. Okay. I mean, you could do a proper calculation here, but it's somewhere between these two numbers, right? If I was going to just do it, wing it off the top of my head, I would go 0.42. Let me see what the mark scheme says. Any answer in the range 0.373 and 0.495. Anything in between these two numbers, pretty much. The answer. Um, the answer to this question, I'm going to tell you the answer now, but that's what the answer is for that one. Because I'm not going to explain, there's nothing to explain, it's just learning a few things. And this is a tough-ish question. Describe how the use of lithium and lithium compounds changed between 2007 and 2017. So use of lithium and lithium compounds. So what I would say is to describe this without real any, you don't have to know any of this stuff. Just read what it says. So in what I would say that since between 2007 and 2017, clearly the amount of lithium used for batteries has more than doubled. Try and put these numbers to it a little bit. So it was 10, it's now 28 or whatever that is. So it's more than doubled. So maybe say that. The amount of lithium used in producing ceramics and glass has also more than doubled, right? More than doubled. So try and put some quantities to these things. Um, And but the amount of lithium used in lubricants has decreased. It was whatever that is, and now it's whatever this is. So put some quantities to these things. Always try to put. Don't just say it's increased or it's decreased. Put by how much and stuff like that. Make sure you always do that with graph questions. That was all of question three. Right, that's nearly done then. Question three done. Four, 7B, 7C. Question four, we've done this one because I just did it in the other one. Exactly the same question. I did it. Exactly the same question. Excellent. Um, because it was in both booklets. And then 7B, 7C. As I say, I won't be doing much more after this, but as a reminder, if you want to drop us an email about the extra thing I'm doing, so I'm doing something tomorrow morning at 9 o'clock, a bit of easy-ish maths, which will be relevant to most people here. As I say, I haven't contacted the year 9 students about this stuff just because. And then there's one at 3 o'clock, which is quite difficult science stuff that my intention is to do. 7B, 7C. 7B. Why are lithium and sodium in group one of the periodic table? Again, you should know that the group numbers refer to the number of outer shell electrons. They have one outer shell electron. And 7C, helium is in group zero. Give one property of helium that is the same as the other gases in group zero. Isn't it that they are unreactive? Would that work? Let me just check. Because everything in group zero is unreactive. Um, Unreactive would be fine. Or a full outer shell of electrons. Okay, let me make sure I've answered everybody's questions. Say it's a little bit shorter, mainly because I'm doing quite a lot of extra stuff this week. 5B. Okay. Okay, so 5B, when you have this formula that says one of these and two of these, basically it's telling you that in order for this to join together, we need two bromine atoms and one calcium atom. That's really all it means. The little two um, means that for every calcium atom, we need two bromine atoms. Let me check if that is the right answer. Um, yeah, although the ratio 1 to 2. Um, in fact, we need to say ions. Yeah, so I'm going to say that there are two Br ions for every calcium ion. It's quite a tricky question, actually. I don't blame you for that one. Um, okay, I think that's it. I'm not going to do any more. Tomorrow at 9 o'clock, if you are in year 10 or year 11, you should already have received the information about this. If not, contact us. And if you're in year 9 and you feel like it, contact us and I will send you a link, which I did put in the chat. So that actually works. You've got it there if you need it. So 9-ish, I will just do various bits of maths for a couple of hours. Then I'm busy from 11 till 1 and 1 till 3. And then from 3 till 5, I'll do a couple of bit of science. And then I'm teaching again from 5 till 9. So I'll see you later. Oh, I should also say, by the way, everybody, I'm going to send an email tomorrow. I can resend the link. Uh, everybody here, everybody who is here right now, you will, not in your next lesson, but in the lesson after that, you will have a test. Just so you know. So it is the weekend of, in case it hasn't been told to you, because I know it hasn't, because it's my job to tell you. The weekend of the 25th, 26th, 27th, around there. If you come, unless, by the way, I think there's at least one person here who has started with us relatively recently, like very recently. Those people are going to try and do something else, possibly, but officially everybody has a test. Um, but as I say, if you are the odd person who comes and has just started a week or two ago, we might see what we can do. But in principle, everybody's supposed to have a test on what we've done in the last few weeks in 2 weeks' time. So from the week commencing the 22nd, technically. So anywhere in that week, you might have a test. Yeah, That's oh god, there's a messages now at the test, aren't there? What will the topics be? For year 11, no topic list. Just, I'm not telling you any topics. And then for everybody else, yes, it's technically, yes, everything. So technically for everybody else, it will be topics we've done in the last few months, which might include things like, oh God, you might have done some organic chemistry. You might have done some statistics and maths. You might have done some, I remember, particle theory, like solid, liquids, and gases. You might have done some stuff to do with, if you're in year 10, you did homeostasis. Other people did some stuff on cells and stuff again because we recapped it. I will send everything tomorrow. Um, oh God. Um, well, if you are not joining, oh God, right. Okay, so that weekend and Sunday is a problem, isn't it? Okay, fine. In terms of those people in Manchester and the marathon situation, we'll deal with that. It might be a case that we just do it the week after. It depends. But you can always, but we'll figure it out. I'll deal with that later. Too many cities. Okay.